The dot plot shows predictions for the winning time in the 200-meter sprint. The winner finished the race in 22.5 seconds. What is the greatest percent error among the predictions? So for the percent error, that's going to be the difference between the prediction and the actual. So you want to take an absolute value for that in order to make sure that it's positive. And then you're going to divide this by the actual. Okay. So the actual that they give us here was 22.5 seconds. So we want to see what is the greatest percent error. Well, for that you want to have the greatest numerator and the smallest denominator. Well, turns out the denominator is going to be 22.5 regardless, because that's the actual time. So that comes down to just finding the greatest numerator. So which one of these points is furthest away from 22.5? Well, 22.5 is over here. That means we have to go to either end to see which one is further. Well, 22.2, that's a distance of 0.3. And then from 22.5 to 22.9, that's a distance of 0.4. So obviously 0.4 is greater. So here we would say, okay, the prediction is 22.9 minus the actual was 22.5. So this is a difference of 0.4 over 22.5. Now the next step is to convert this into a percent, but first we have to write this as a decimal. So one way you can do this is multiplying both sides, or top and bottom, by 10, give you 4 over 225. And from here, if you multiply the bottom by 4, the top and bottom by 4, yeah, we get 16 over 900. And so this you can simplify by dividing the top by 9, and then the bottom just keep it as 100. 16 ninths is just 1 and 7 ninths, which we know that 7 ninths is 1.7 repeating. So when you divide it by 100, you're moving the decimal twice to the left. So that's going to be 0.017 repeating, which if you round this to, if you put this as a percent, you move the decimal twice. So this would be 1.77 whatever percent. So the sevens are repeating, which we say that this is 1.8% rounded to the nearest tenth.